Good morning, students. Welcome back to our digital signal processing class. In today's class, we are going to continue our same discussion. In today's class, we are going to see the problems related to DIF FFT. Before proceeding for today's class, let us take an overview of a previous class, what we have discussed in previous class. In the previous class, we have discussed the problem related to DIT FFT for 4 points and for 8 points. In today's class, we are proceeding with the problem of 8-point DFT of the sequence. They gave one question. Find the 8-point DFT, discrete Fourier transform of the sequence x of n, 1, 2, 2, 1, again 1, 2, 2, 1. They gave this sequence. They asked to using DIF, that is decimation in frequency fast Fourier transform algorithm. So by using this, we need to realize our function for 8 points. So what we need to find out? So same thing, we need to find out its n domain sequence into k domain sequence. That is nothing but DFT, discrete Fourier transform. But here we need to use DIF FFT algorithm. For that, what we are using? We are using the butterfly diagram for 8-point FFT. So we have taken, what is this in this side is called? This is nothing but input stage. So we are taking input stage. What are the inputs value for DIF FFT? What is this steps we need to use it? First step is that the input should be in normal order and output should be in bit reverse order. That is the first point. So for doing this kind of questions, we need to keep that point in our mind and we need to take the inputs and outputs. So for that, what I'm doing? I'm using input end, then I need to go for stage 1 analysis, stage 2 analysis, then I'll get the output. So what is the input value I need to use? I need to use in normal order, x of 0, x of 1, x of 2, x of 3, x of 4, x of 5 and x of 6 and x of 7. So these are my inputs value. So inputs value, what I'm taking? I'm taking in normal order. So I've taken all the values of x. Next thing, I need to write. What I need to write? It's output. The output should be in which order? Output should be in bit reverse order. What is the meaning of bit reverse order? The first should be x of 0. The next would be x of 4. So difference of these two bits needs to be 4. Similarly, next would be x of 2 with x of 6. So difference of both of them would be what? 4. Similarly, for odd, x of 1, x of 5, x of 3 and x of 7. So I mentioned input as well as output for given particular sequence. Next thing, I need to write those respective values. So what is the respective values I need to write? X of 0, x of 1, 2, 3, 4, 5, 6, 7. So these are my input sequence in that particular order. So this is my 0th position, first, second, third position, fourth, fifth, 6th and 7th. So these are my values. So I need to mention that position values in with respect to the input value. So what is the first input I do have? 1. Next 2. Next 2. Next is 1. Again 1, 2, 2 and 1. Right? So now which algorithm we are applying? We are applying DIF FFT algorithm. So by using DIF FFT, we are finding the function for that particular sequence. So what we'll do it? For DIF FFT, we'll leave these 4 dots. We'll start from this end. 1 with this part. So 1, 2, 3, 4 we left. We join the first with this 4th one. Next would be for the next dot. Next would be with next dot. Next would be with next dot. So what we have done? We have taken the starting 4 inputs with remaining 4 inputs. Now what is left out? We left with remaining 4. We'll combine with starting 4 stage 1 inputs. So here we stop it. So this is your first input, second, third and fourth. So we made it like this. So what is the omega values we'll write? This is a weighting sequence. Omega 8 power 0, omega 8 power 1, omega 8 power 2, omega 8 power 3. Right? These are our feedbacks, right? So this has to be minus 1. So this is what? Minus 1. This is minus 1. Again, this would be minus 1. Like this, we mention all the values. So we wrote it, feedback values we mentioned with minus 1. So now we need to write the stage 1 output. So stage 1 outputs we need to write down. How do we write? We need to get for first. What is the first input? X of 0, that is 1. 1, 2, 2, 1. Again we do have 1, 2, 2 and 1. Right? So these are inputs value. Now we are going for stage 1 analysis. In stage 1 analysis, what are the two values for this? This is our first input, right? This is our second input. So 1 plus 1. So I can write here, for first one I do have 1 plus 1, that is written as 2. So that is 2 is the first value. Likewise I can go for the second one. Here is coming point is 2, right? Here is what? 2. So 2 plus 2 it is 4. So I'll mention 2 plus 2. I get it as 4. Similarly for the next one. So this I have made it. I combine it. Similarly for the next one. Here is 2, right? So here is 2. Again 2 plus 2 it is 4. For the next input I can write 2 plus 2. We got it as 4. Next input value we do have 1 here. Again 1 here. 1 plus 1. Again 2. So I can mention for this 1 plus 1 is 2. Now for the next input what we'll take? We do have 1 here. We do have minus 1. So 1 minus 1 of omega 8 power 0. So here I'll mention like this. 1 minus 1 omega 8 power 0. For both, then you multiply with omega 8 power 0. Likewise I can write for the next one. 1 minus omega 8 power 0 is 0 only. Here 2 minus 2 omega 8 power 1. So I can write for this 2 minus 2 omega 8 power 1. Next would be omega 8 power 2, omega 8 power 3. Whatever the value is there, we'll multiply with omega 8 power 2, omega 8 power 3. Weighting values, weighting sequence. So we know what is our weighting sequence. Omega 8 power 0 is 1. Omega 8 power 1 is what? 0.7. That is 1 by root 2 minus j by root 2. That is 0.707 minus j into 0.707. Then omega 8 power 2 is what? Actually it's 90. So minus j. So omega 8 power 3 is what? Minus 1 by root 2 minus j by root 2. So these values we need to consider while we are taking this particular problem or any problems related to DITFFT or DIFFFT. So what we are getting? This we are getting it as 0 because 2 minus 2 is 0. So likewise we do have next one. 2 again here is 2. So 2 minus 2 again it is. So 2 minus 2 again it is 0. 1 minus 1 again this is 0. This is also 0 because 1 here there is also 1. So those values we wrote it. We got the stage 1 analysis. So what we have done? We found for stage 1. Next is that we need to go for stage 2. So till now what are the values we wrote it? These values we found. So now what we'll do? We'll leave these 2 points. We'll take the next 2 points. We'll join it. So what I'll do it? I'll take this next input where I need to move this one. Next one with this. Right? So I wrote this next values. Next thing, we have these 2 inputs, right? So first inputs we'll join with first. So I'll join the first with first, second with second. Clear? So what I did? I have combined first 2 with next 2 with first 2. Like that I have made it. So what is the values we got it? These are 4 inputs. Here 2 and this is 2, 4 and 4. So we need to join it. So we done with 2. This is with 4. So this is not that one. Already we made it, right? This needs to be come with first one. What I'll do it? Don't make the confusion in that. So whenever you draw the lines, line needs to be proper. So see once again. So first this one with this. We left with 2 dots. This one with that next one. So we do have this part. That needs to be with first. That needs to be with second. Similarly, leave these 2 dots. Join this with next one. So what I join? This with the last. This with this one. Similarly, this with first. This with the next one. So what is the feedback we do have? Here we do have is feedback. So this should be minus 1. This is also we do have feedback. It's minus 1. So here also we do have feedback. It is minus 1. Here also we do have feedback is minus 1. So what is the omega values we need to write here? Omega 8 power 0. Omega 8 power 2. Similarly, omega 8 power 0. Omega 8 power 2. So we have mentioned all those values by taking the omega. So what is omega value we do have? We have omega 8 power 0 for the first input. For the second input, omega 8 power 2 we have taken. We'll write that values by considering these all factors. So the next thing we need to write its values. So what we'll write? We'll write down next stage 2 inputs. Where it is coming from? It's coming from this 4 plus 2. So what I can write for the stage 2 inputs? So I do have these all are zeros. So here we are getting what is the first input? 2 plus 4, that is 6. So 2 is coming from this end and 4 is coming from this end, it is 6 again. So we got this first one. Similarly, for the next 4 is coming here and 2 is coming here. Again it is what? 6. So next is input is also same. Similarly, next here 2 minus 4 of omega 8 power 0. So what I'll write? 2 minus 4 of omega 8 power 0. Omega 8 power 0 is 1. So this is nothing but minus 2. So what is the value here? We do have minus 2. Similarly, 4 minus 2 of omega 8 power 2. So 4 minus 2 of omega 8 power 2, that is nothing but 4 minus 2 is 2. Omega 8 power 2 is what? Omega 8 power 2 is minus j. So minus 2j. So what is the value here we got? Minus 2j. Similarly here, 0 minus 0, it's 0 because this line is 0 coming here. 0 coming here and then 0, it is also 0. This is also 0, this is also 0. So remaining all are zeros. 2, 3 and 4. Clear? Next thing, direct we need to write the output. So what is the output of first value? X of 0. How do we combine this one? 1 with second. So 1 with second. So 1 with second, again 1 with second. So what is the feedback we do have? We had feedback here, it's minus 1. We do have feedback here, minus 1. We do have feedback minus 1 and we do have feedback is minus 1. So we mentioned. Next we need to write the output x of 0. So what is the output x of 0? X of 0, first one. Next x of 4. X of 2 with x of 6. Next x of 1 with x of 5. X of 3 with x of 7. So we need to write those values. So how do we write x of 0? Input 6 plus 6, it is what? 12. So what I'm doing first, we got 6 plus 6, it is what? 12. Next thing, x of 4. 6, again minus 6. 6 minus 6 is what? 0. So here, feedback needs to do omega 8 power 0. Omega 8 power 0. Omega 8 power 0. Omega 8 power 0. So wherever is there, that point we mention the twiddle factor with that particular number. So next thing, x of 2. What is x of 2? It's minus 2. Again minus 2j. It is minus 2 minus 2j. So that value we need to write. Second we got 6 minus 6, it's 0. Next is minus 2 minus 2j. We got it. Minus 2 minus 2j. Next, here is minus 2. Here already minus feedback. It is what? Minus 2, this minus and this minus, plus 2j. So for the next one, what I'm doing, what I'm getting? Minus 2 plus 2j. Similarly, x of 1. What is x of 1 value here? It's 0. 0 minus 0. X of 5, 0 minus 0. Next, x of 3. What is x of 3? 0 minus 0. X of 7, again 0 minus 0. So remaining all values we got 0, 0, 0 and 0. So we found the DIF FFT for given sequence. So what we have done, students? We have done input taken, input in normal order we have taken, output in bit reverse order. Next thing what we have done, for stage 1 analysis, we left starting 4 points, we combine with remaining. So remaining 4 dots, whatever dots is there, these values we combine with it. And we mention these are what? W8 power 0, 8 power 1, 2, 3. This 4, starting 4s. In the previous one when we go for DIT FFT, that values will go for this feedback side will write. Here forward path we need to write because it's reverse of your time domain. Here it is in frequency domain. So for the frequency, the first lines, whatever the butterfly first line is there, that point we mentioned and we wrote it. For the next second stage, starting 2 would be omega 8 power 0, omega 8 power 2, omega 8 power 0, omega 8 power 2. For the next one, for stage 2 analysis, omega 8 power 0. Twiddle factor needs to be the first line, we put it, and for the feedback we mentioned minus 1. So this is the way we have taken all the inputs, stage 1, stage 2, then we wrote it output. After that, output is not in proper order, right? We cannot write the output in this order. Output needs to be written x of 0, for this is first answer, then x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. So these values needs to be written in particular order in order to write the given sequence. That is nothing but the particular sequence in x of k form. So because the discrete Fourier transform, whenever we want to find out the values for it, that n domain sequence can be converted into k domain sequence by writing the respective output values for that particular sequence. So before proceeding for the next topic, just note it down this part. So we got the students x of zeros 4, 2, 6, 1, 5, 3 and 7. So we know by using DFT. What is the DFT is all about? Your n domain sequence can be converted into k domain sequence by applying DFT. That is nothing but discrete Fourier transform. So in that, if you do have input sequence, DFT of x of n can be written as x of k, right? So now what we are doing by using DIF FFT. So what we are doing, x of n. What is the x of n value we do have? This is nothing but 1, 2, 2, 1, 1, 2, 2 and 1. This is an x of n. Now by applying this one, what we just want to write, we want to write x of k. So first would be x of 0. Next is x of 1, x of 2, x of 3. Next x of 4, x of 5, x of 6 and x of 7. So these values we need to write. So what we'll write? X of 0. So what is x of 0 we do have? It's 12. It's 12, comma, x of 1. So x of 1 we do have 0. So this is 0. X of 2, minus 2, minus 2j. X of 3, again it is 0. X of 4, what is x of 4 we do have? Again it is 0. X of 5, so x of 5 is 0. X of 6, minus 2 plus 2j. X of 7, it is 0. So this is our x of k sequence. That sequence, if you want to convert into DIF FFT, we can convert x of n sequence into x of k by applying this particular part. Don't write directly this answer in that particular order. It is not in order. It is in which order? Output is in bit reverse order. So but the output should not be in bit reverse order. We need to write in that particular sequence form. So sequence needs to be in sequence wise. Whatever the position values are there, that position values we need to write. As per that, your answer has been obtained. So this is the question for finding the DIF FFT. They'll give different values for it to find out. That value we can do as per using the sequence of that particular form. So this is the way you can find the sequence of DIT FFT or DIF FFT. By using this particular part, we can convert the sequence. So we'll see once again, students. So what we have done, they gave a sequence x of n, that is 1, 2, 2, 1, and that one they just give the sequence in that particular order. We just taken in the input in normal order. We wrote it all the values and we'll try to write the next one, stage analysis. So in that what we have done, how do we got this 2? First 1 plus 1, that is nothing but 2. Similarly for the second one, how do we get the 4? This input line. For this one, next input line, 2 plus 2, it is 4. How do we get the 4? Again, this is 2 plus 2, make it as 4. How do we got this 2? This line 1 plus this one, it is 2. How do we got 0? Minus 1 and minus 1 minus 1 is 0. So likewise, we went for stage 1. For stage 2, how do we got this 6? This input, now this is the input, not that one. Don't look at into the starting one. The one which is there at the stage 1, that is nothing but your input values. So for that we'll have taken these all inputs values. We wrote the first one. So how do we, the first line is coming from this stage 1. So this is our 2 and this line we should take, not the second one. The line where it is coming from, there you need to look it into it. So 2 plus 4, make it as 6. Likewise, I can go for the next part. I do have is 4 here. And again, I do have is 2 here. So 4 plus 2, again make it as 6. For the next one, I do have, what is the next one? It is 2. Here, 4. So 2 minus 4 of this omega 8 power 0. That is nothing but minus 2. So before doing this all, you need to keep in your mind all these values. Omega 8 power 0, omega 8 power 1, omega 8 power 2, omega 8 power 3. What is omega 8 power 0? Weighting sequence, if you put the value, it's 1. Omega 8 power 1, how do we substitute? In the twiddle factor, e power minus j 2 pi kn by n. N is nothing but number of samples. So we had 8 samples. We have seen these kind of thing in the previous class also. While we are discussing these concepts, butterfly diagrams for radix 2, DIT FFT, radix 4, DIF FFT, we have discussed these concepts. So that is nothing but we just want to go for stage 1 analysis. Before doing it, we should know omega 2, 1, omega 2, omega 3, all those values. So we got stage 2. From stage 2, we moved to the stage 3, that is nothing but our complete output stage. This is the way we found the output by going for these analysis. Input 2, stage 1, how do we got? stage 1 to stage 2. The values may not be same in exam. 1 to 2, 1, they can give 0, 1, minus 1, anything. As we have seen the previous problem, they can give any sequence. You need to solve it. For sure, you will get this butterfly diagram, either decimation in time, decimation in frequency. What is the difference of both? In decimation time, this is our input sequence. This will become at this part. Then this input will become at the output part in decimation in time, DIT FFT. Whereas in DIF FFT, that input is come at the output side and output is come at the input side. It's quite vice versa for each other. It's reverse of it. Reverse operation will apply while we go for DIT FFT. So DIF FFT, we just found the sequence, we wrote it. This is the way you need to solve the questions. If they ask in exam to solve it, you need to draw the diagrams and you need to go for analyzing this thing and writing the sequence in proper order. That may give you 10 marks question. So this is also 10 mark sure question for external exam. For external exam, this is the question they'll keep on giving. So students, in the next class, we'll start the unit 2. In unit 2, what is the things we need to cover? We need to cover the next concept, that is nothing but IIR filters. What is IIR filter is all about and where it will be useful. There is a different concept of Butterworth approximation, Chebyshev approximation. By using it, we are going to go for IIR filtering. That point and that concepts we will see in the next class. Thank you. Thank you for today's class. Just make the notes of it and try to practice the questions. Which I'll give one question to solve it. Try that question by applying DIF FFT. And if any query you do have, you just mail me. I'll give my mail ID in description box, or else you can message me. I'll give it. Thank you. So take this question, students. So find the 8-point DFT of the sequence x of n. So we need to find 8-point DFT. That is nothing but discrete Fourier transform of the sequence 1, 2, 3, 4. 4, 3, 2, 1 by using DIF. So by using DIF FFT algorithm. So by using DIF FFT, it's the same thing. You need to solve that question. So the first thing, write the position values and input should be normal order and the output should be in bit reverse order, and find the respective stage 1 analysis, stage 2, then the output by using the butterfly diagram for that DIF FFT. So do it and send me the answer.